So let's talk about the course topics here. This is Module 6 of 6. This is our last module. We'll begin to focus on automating software tests in this module. We'll first start out with test automation. We'll go into test automation strategies, then move to writing automation tests, and then managing test scripts. So let's get started. So we'll start with understanding test automation, 6.1. In this section, we'll review the benefits of test automation, candidates for automation as we think about the different tests that are out there. What are some of the best that we would consider as candidates for automation? And then the automation process. Our guiding questions for this section is, what is the difference between automated tests and a manual test? What are the benefits of automated testing? And what are names of two types of tests that can be automated? So we've talked about automated tests before, Eric. It's really taking a set of steps that a tutor can perform programmatically to test the functionality of the software. We know that automated testing definitely complements manual testing. It doesn't replace it, but it complements that. And automated tests need to be created by a developer, while the manual testing can be conducted by someone without programming skills.
Right, and when we say developer in this context, we're talking about the developers or the SDETs, who are the software development engineer and test. That's included in developer when we're talking about this.
Great. So there are plenty of benefits of automated tests. One, it helps maintain stability and helps find regressions that might occur because of code changes. The automated tests, nicely enough, you don't have to have resources to run the tests. They can run automatically. The automated tests are software applications and can be designed and composed of other reusable code. Automation can be run on multiple configurations, so we think about the different Microsoft platforms. Nicely enough, Microsoft Test Manager can help us go drive that across multiple configurations.
Right, and on top of that, these automated tests, you can set them up to handle the boring, repetitive test cases.
Yeah. There are some drawbacks of automated testing. Eric, you deal with automated testing on a day-to-day basis.
Right.
So tell me a little bit about what you see as drawbacks, and then we'll go into some of the common tests that you think are good candidates.
Yeah, when code is changed and refactored, especially when there's a lot of code churn going on, your automation's going to break. And that has a real distinct bummer effect on the team. I mean, when you've put a lot of work into the automation and you spend all your time rewriting your automation versus just executing your automation code. And also, once you've got things automated, there can be a tendency to kind of step away from it and let the automation do its job to the point where you may have a false sense of security.
So what are some common tests that you have seen automated?
So the unit tests you're going to want to automate, and load tests you have to automate. And then you've got your continuous integration tests, through Visual Studio, Application Lifecycle Management. You can ensure that whenever code is developed and checked in, it works correctly with the code. That just runs when you check in.
So what are some other potential candidates that you have seen or used before?
So you've got configuration testing, UI tests, your user interface, and then your installation tests. Those are all great candidates for automating.
Okay. So there are some barriers to automation. So when we think about some of the costs that are associated with it, there's definitely a business justification that has to happen before you go ahead and create these test automations. So tell me a little bit about some of the other considerations that you have to think about.
Right, that takes a planning and a front-loaded effort to create the automation, and it takes a team that has the skill set to automate that code too. Also, like we mentioned in the previous slide, if you've got code that's changing frequently, you're just shooting for a moving target. It's going to be really hard.
Yeah. What about code that's kind of bound to the UI?
Right. There are tools to do that, I mean, you've got the coded UI tests you can do.
Yeah.
So
And that's built right into Visual Studio.
that's built right into Visual Studio.
All right, great. So as we think about the automation process, so how do you get from like, a manual test case and you decide that you want to move to an automated test case? What are some of the steps you got to think about?
Well, you have to think about what are the cost-benefit analysis of doing that move. So, and then once you've decided on it, you're going to really lay out that test case and put a lot of thought into it. You're going to create that automated test case. You're going to check your test project, make sure that the test project is part of the build definition. You're going to associate the automated test with that build. And now the automated test is going to run whenever the build is kicked off.
Okay. Sounds like a simple process. Does it take a long time to do?
It's complicated. Okay. And once you get into it, it's a real value add.
So let's talk about the section questions for this 6.1 section here. What is the difference between an automated test and a manual test?
An automated test runs unattended,
while the manual test is really kind of conducted by a human.
Right.
Yeah. What are the benefits of automated testing? We've talked a lot about them.
Right.
Kind of give us, what do you think is the top benefit?
So I'd say, well, there's quite a few benefits from it, and depending on your project, will depend on what benefit you're going to get. You're going to get speed. You could potentially get more coverage. You can run this unattended, so it can run overnight with each build. You could do a daily build and run it every night. And like I said before, it can handle these repetitive, boring tasks.
Okay. And what are names of two types of tests that can be automated?
So I'll give you three: unit test, a load test, and a UI test using coded UI.
Awesome, great. So let's move on to 6.2, test automation strategies. Inside of this module, we will review logging and automation priority. So the guiding question for this section is what feature enables automatic logging in Visual Studio? Now, for those of you that have already looked at some of our other modules, you already know the answer to this. Eric? So when we think about prioritizing automation, what are some of the considerations that you see are important?
Well, in test-driven development, it's a must. I mean, that's part of the process. Integration, and then we'll talk about integration test being the top priority for units which are combined into components. So that's a must as well. When you're deciding on which manual tests should be automated, you got to consider things like how often is it going to be run, how often will the code likely change, like how much churn is there going to be, and then how much time are you going to save by running this unattended. If your regression pass takes a full day and you can have your automation run all night, and in the morning you can see what all the bugs are, that's a great value add.
Sounds good to me. So our section question is, what features enable automatic logging in Visual Studio?
That's IntelliTrace.
So let's move to 6.3, writing automation tests. In this section, we'll review logic, testing logic, error handling, commenting, and also virtual machines. So our guiding questions for this section is, how is a virtual machine different from a physical machine? What is the name of a condition test used to check logic and debug builds? And then what happens to these condition tests in the release build? So testing logic with assertion. Now, tests, whenever you test a condition during a program execution, you can do that with assertion, and if the assertion is true, then no action occurs. But if the assertion is false, then assertion has failed.
Right. So think of an assertion as your actual test. So you've got your automation code that's going to have an action, and the action will complete, but the automation code doesn't necessarily do anything else. So if I have it put in a value, how am I going to know if the value is doing what I think it does. Well, that's where the assertion comes into play. So in the automation, I'll put an assertion. The assertion is my expected results that I would expect from my manual test case. So automation opens a page and writes a name. The assertion validates that the name shows up properly. If the assertion passes, the automation continues on. If the assertion fails, then the automation does whatever I specified in that assertion for it to do, whether I want it to log an error or I want it to send something to a log file.
So we can find errors in testing. So I think that everybody knows that if it's a human that's developing the code, there's an easy opportunity for us to also create errors in our test scripts. So you may have test level errors, or you may have run level errors. Can you talk a little bit about the differences between those two, and how does based upon either the agile methodology or maybe even waterfall, how do those get addressed?
So a test level error is essentially just like a test timeout. Okay. And the run level error is going to be like a runtime error.
Okay. Now, would you log these errors or these bugs, these test errors, similar to just a standard bug in the agile process and put those back into the stack, or do they get addressed at a higher priority?
No, these will get prioritized in the triage meeting, just like any other bug is going to get triaged. Right. So you get as much detail into these bugs as you can, and then you let the triage meeting set the prioritization on those.
Great. Test comments. So you and I have talked a little bit about Test Runner and using Test Runner. Give us some insight there.
Yeah, as you're writing any kind of your automated tests, you're going to want to put as many comments in there as you can, because when you have issues with, when it finds a bug, you want to know kind of what's going on. But when you've got bugs in your test code as well, those comments are going to help you out. Okay. So you can want to comment your code just like you want your developers to comment their code. So when something's not right, you can identify that much more quickly.
So is this in Test Manager, or is this just part of Visual Studio?
This is part of Visual Studio.
Okay, great. Now, virtual machines. We've talked a little bit about virtual machines in previous modules. Virtual machines are basically just a machine in a machine, leveraging software to emulate the hardware components of a CPU. Nicely enough, these virtual machines can be used as a part of your test lab. So as you think about test automation, test scripts, being able to do that across multiple VMs is highly productive. Also reduces what your hardware cost is as you think about these large labs. I remember when I first came to Microsoft, you'd go into the lab environment, and it would just be a huge room with servers and machines and printers and those types of things. Today, you don't have to do that. You have your virtual machines, and they'll help you emulate a lot of the operating systems that you want to test against. Setting up a VM, you need to test the different configurations without purchasing additional computers, as I mentioned. But at the same time, you can manage these all in one setting using using additional tools like the System Center VM Manager, which is also a great tool. So if you think about how you manage the states of those testing machines, System Center can help you go do that. So let's now move into the section questions. First question is, how is a virtual machine different from a physical machine?
So virtual machine is software-based, and you can have several virtual machines on a Windows server.
And what's the name of a condition test used to check logic in debug builds?
That's an assertion.
Okay. And what happens to these condition tests in a release build?
They are ignored.
Okay. So let's move on to 6.4, managing test scripts. In this module, we'll talk about smoke tests, build variation tests, and also lab management. So what are two types of lab environments? That's one of our first guiding questions. Next is, what does the BVT stand for? And then what type of machines can a System Center Virtual Machine Manager environment manage?
So we'll start with smoke testing. The term smoke test describes the process of validating the code changes before the changes are checked into the product source tree. So essentially what that means is developer feels like he's got his stuff ready to check in right before he checks it, and he runs a smoke test.
Cool. And, so smoke test focuses on the features of the software that are most likely to be affected by a recent change or addition. So you can also do kind of a quick smoke test on maybe a quick update or a quick change that you have. Or maybe reactivate a bug and you just need to make a quick change to maybe a data type or something like that. You can do a quick smoke test and then be able to throw that back in and get that bug verified. Build verification test. I think I just kind of let the cat out of the bag on that one.
Yeah. So smoke test is validating the code changes before the change. Oh, sorry about that. I backed up on my slide. Smoke test. We're talking about BVT now. So this is kind of similar to a smoke test. This is something that we'll do a lot of. We'll do a build verification test in test. So this is the first thing we'll do when we get our hands on it. So we'll run our Pry1 test cases, we'll run through our happy path, we'll kind of do our critical path, which is kind of the fastest way through the application. And the smoke test for us is always part of our entry criteria. So if it doesn't pass the smoke test, generally we're going to reject the build because if it can't pass the smoke test, there's just going to be too many blocking issues in the code that we're not going to be able to make enough progress on the test team. So we're going to be better off if we kick it back to development, have them spend a few hours on it, get it fixed to the point where it can pass our smoke test, and then we're going to be able to be more productive in test.
So it sounds like build verification tests are really kind of a risk mitigation as you think about moving that, moving that code up and making sure that you've got an appropriate build.
Oh, that's right.
So lab environments. So it's interesting as you think about your testing strategy, you think about the multiple systems that you'll be testing your software on. Perhaps it'll be different hardware or different operating systems. So rather than manually having to reconfigure a number of machines for each one of the different tests, for each one of the different operating systems, Visual Studio has something called Lab Management, which handles the configuration, deployment, and testing of these tests. The lab environment, as we've talked once before, is a collection of computers, whether or not they be individual computers or whether or not they be multiple VMs, managed by System Center's VM Manager. So there are some advantages of having a lab environment. First, as you think about the results of tests across different OSs, across different testing scripts, you're able to go show tests across your environment, which really shows, I'd say, the level of breadth that you're doing in your test. But at the same time, as you think about those tests, the test scripts that you're doing, we can really begin to talk about the depth of testing that you're doing on certain aspects of maybe that application in certain OSs. The Lab Manager helps you to automatically install both the test agents on each machine, enabling the test to be collected. But then also you have inside the lab environment, it'll also help you manage the allocation of machines to test for reasons that include preventing like two team members from mistakenly assigning the same machine to different tests. So there's two types of lab environments. One is the standard lab environment where you have physical machines, and then there's the SCVM manager environment where it only contains virtual machines that are controlled by System Center. So there's some key features for the System Center virtual machine manager. First is environmental snapshot. So nicely enough with SCVMM, you can take a snapshot of the entire state of the lab environment. So you can quickly clean that, basically wipe it, and then also rebuild it really fast. This saves a lot of time in regards to load time and helping you establish a base state of the environment. Also, the nice part about SCVMM is it provides network isolation. And that means that it will take your environment and you can multiply that testing environment across multiple VMs without having computer name conflicts, which is really, really nice. You can also create virtual machine templates. With VCM, SVC, oh wow. SCVMM. With those environments, you can basically establish a template. With that template, you're able to replicate that template across your virtual machine environments. So it helps you with that constant wiping and also reloading of that environment. Also helps you in regards to replicating that virtual machine structure. And then finally, you can store virtual machines. So after I use my template, I can store that virtual machine in a team project library. So I can pull that out at any point in time and begin to use that state of that virtual machine. So some of the supported operating systems for virtual machines. Today we have XP/SP3. I doubt we're going to provide later versions than that, but that's what was instructed as a part of this course. Windows Vista, again, concerned about that. Windows Vista is no longer supported, so I'm not for sure exactly how we're going to support those VMs. We also have Windows Server 2003, 2008, 2008 R2. Windows Server 2012, Windows 7, and Windows 8 or a later version. That should say 8.1, shouldn't it?
It should say 8.1.
8.1 or a later version. So here's our section questions. What are two types of lab environments?
Well, you've got your standard lab environment, and you've got your...
Virtual.
Can you say it? SCVMM?
SCVMM, yes.
Okay.
Thank you.
Good job.
Appreciate that. What does BVT stand for?
So that's the build verification test.
Which is also a
That's a smoke test.
smoke test. And what type of machines can a VCV, no, SVC,
Come on.
SCVMM
There you go.
environment manage?
Pretty much any Windows machine.
Yes. Primarily virtual machines.
Right.
So some of the supported operating systems for virtual machines. Today we have XP/SP3. I doubt we're going to provide later versions than that, but that's what was instructed as a part of this course. Windows Vista, again, concerned about that. Windows Vista is no longer supported, so I'm not for sure exactly how we're going to support those VMs. We also have Windows Server 2003, 2008, 2008 R2. Windows Server 2012, Windows 7, and Windows 8 or a later version. That should say 8.1, shouldn't it?
It should say 8.1.
8.1 or a later version. So here's our section questions. What are two types of lab environments?
Well, you've got your standard lab environment, and you've got your...
Virtual.
Can you say it? SCVMM?
SCVMM, yes.
Okay.
Thank you.
Good job.
Appreciate that. What does BVT stand for?
So that's the build verification test.
Which is also a
That's a smoke test.
smoke test. And what type of machines can a VCV, no, SVC,
Come on.
SCVMM
There you go.
environment manage?
Pretty much any Windows machine.
Yes. Primarily virtual machines.
Right.
As we've talked about, we have additional resources for each one of our modules. I would say inside of this, there's a number of walkthroughs. I would definitely take the time to go through the walkthrough resources. Also, there's a unit test, unit testing inside, testing the inside. There's also lab environments and also troubleshooting test execution, which I would also recommend highly. So before we end today, understand that this course can easily be a stepping stone for you to move forward in getting a Microsoft Certified Solution Developer certification on application lifecycle management. There are many learning partners that we have that would love to engage with you, help you get the training, and help you prep for the MCSD exams. This is the end of Module 6 of Software Testing Fundamentals. This happens to be the last module of this course. We would hope that you would continually look at Microsoft Virtual Academy for additional software testing courses, especially those that are focused on the application of software testing. I think that'd be very important and also be of value to many of you that have gone through these modules. We want to thank you for being a part of Microsoft Virtual Academy and taking this course. Thanks and take care.